Changing land. Explore 2. How do landforms change over time? We're continuing to explore this question in another investigation. This time, we're looking at how does ice or glaciers affect or change landforms. We know that in this scope, we're learning how to make observations and/or measurements to provide evidence of the effects of weathering or the rate of erosion by water, ice, wind, or vegetation. In this particular activity, we're going to learn more about how glaciers, or large masses of ice, affect our land and our landforms. You'll be successful when you can use your observations and measurements to describe changes to the land. And you know you'll be successful when you can answer the science question using specific examples from those observations. So for this investigation, we're looking at how ice affects or changes the land. Now, millions of years ago, where we are in Connecticut, was covered with giant glaciers. Glaciers made up of thick, heavy ice. And the thing about glaciers, as you know, is that they move because they're made of water, so they're constantly melting and refreezing and melting and refreezing. So that movement of water's never static or staying in the same place. Even though it doesn't look like they move, they are constantly moving. So we've set up our rock face, or our land that they were going to imagine our glacier on, and I've got 3 different sizes of glacier that we're going to look at. We've got a small glacier, a medium glacier. Let me actually swap that out. Maybe this one is the medium. Okay. And a much larger glacier. So to start, we're going to start with our small glacier. And again, if you have sand and ice at home, you can try this out and see the effects up close. We're going to make observations of what happens when that glacier travels over land. So I'm going to move my glacier over the land. And we'll leave it right there. What do you notice? What observations can you make about how that glacier changed the land? Think about the terms weathering, erosion, and deposition. Do you see evidence of weathering or the wearing away, breaking down of the land? Do you see evidence of erosion, or where the sediments are moved away from where they were? And do you see evidence of deposition, where the sediments are left, or where they end up? We know that good scientists always make measurements. So I'm going to measure how deep a trench. So let me see if I can make it a little clearer. So the trench goes here to here. So I want to measure the different distance between those two. Now I'm a little bit stuck because my ruler, I can't get my 0 because of the size of my box here. So I'm going to line up my ruler at the 20 mark, and I'm going to, it's 20 millimeters, so there's between 20 and 30 is 10, and 20 and 30 and 40 is another 10. So my total trench is 20 millimeters. All right, that was my small glacier. So take a minute and see if you can summarize the ways the small glacier affected or changed the landscape. While you do that, I'm going to reset for the next trial. Okay, so for trial number 2, I'm going to use the larger or medium-sized piece of ice to represent a medium-sized glacier. I'm going to use the same amount of force. I'm not going to push it harder or softer than I did before, or I'll do my best. So that's not a variable that changes the effect on the land. I really want to know, how does the size of the glacier, the mass of the glacier, affect the land? So I'm going to start at the top. As I go, What did we see happen this time? Can you describe evidence of change? Can you describe evidence of weathering, erosion, and deposition? I'm going to put my glacier at the bottom there. Okay. Let's take our measurements. So I'm going to make the lines between the channel there. Use my ruler. I'm going to line it up with a 10. I can see it's 10 millimeters, 20 millimeters, 30 millimeters. So we have a difference in the width of the trench it created. I want you to think about the observations you can make, both things that you see with your eyes as well as the measurements we made to describe the changes that the medium-sized glacier made on the land. While you do that, I'm going to reset one more time. Okay, I've reset my model and I'm ready to test out the effects of the large glacier. So if I show you side by side, you can see that the large glacier is a little bit bigger than that medium one. Far away it looked about the same, but up close you can see it's quite a bit bigger than that medium-sized glacier. Alright, so my glaciers are melting as we speak. Whoops. And they're a little slippery. Okay, again, we're going to keep the amount of force the same as our last trial, because in an investigation you want to change one thing at a time, and the thing that I'm changing, our variable that I'm changing, is the size of the glacier to see the effect on the land. Here we go. Okay. Take a close look there. See the trench that was created by that glacier. Okay. And you can begin to describe how that glacier affected the land, the shape of the indentation it made on the land. You can also look for evidence of weathering, erosion, and deposition. Let's take a measurement. Ooh, this time it's wide enough. I can start at 0, and that makes it a little bit easier because I can see that the trench is almost 50 millimeters wide. So we went from 20 to 30 to 50. So given that data, what's the relationship between the size of the glacier and the size of the trench or markings it leaves on the land as it travels? All right, make your final observations about the effect of large glaciers on the land, thinking about what we can see as well as what we can measure. Thanks for joining me in science class today. See you next time.